So, we are discussing about the software controlled serial data transmission. So, the second example is interfacing a CRT terminal to 8251 to transmit ASCII characters. Word consisting of ASCII characters. So, I will assume the same specifications as the earlier example. So, the specifications that we have taken here are the character length is 7, no parity, 2 stop bits, transmitter clock frequency will be 153.6 kilohertz and baud rate is 9600. So, that we have got this baud rate factor as 153.6 into 10 to the power of 3 divided by 9600, this comes to 16. So, these are the different specifications. So, to meet these specifications, so we have constructed this mode word as CAH and command word as A11H. So, this mode word command word together is called control word and as well as a status word. The address of this one will be so for the interfacing circuitry that I have discussed earlier. So, this will comes to all this will comes to FFH, FFH and for data register this is FEH. So, with these specifications I will discuss how a CRT terminal can be connected to 8251 to display some words consisting of ASCII characters. So, we have these connections between 8086 to 8251. So, A0 to A0, read bar to read bar, write bar to write bar and so on, and chip select door we have generated using NAND gate through the lines A1 to A7. So, that we will get the addresses of FE and FFH, the chip select signal. So, read bar will be connected to IO read bar, write bar will be connected to IO write bar. So, these are the various connections between 8251 to this. Then transmit data pin will be connected to transmit through MC1488. This will be connected to RS232 interface. This is to this is transmit. This will be connected to CRT terminal. Seven is ground. This is RS232C cable. Now, I want to display on this CRT display in the first line. This is CRT display. So, starting from here, I want to display hello, this character, and I want to return to the starting of next line. So, for that the ASCII characters correspond to hello is, as I have told, capital A to capital Z, the ASCII characters will be 41 to 5H. So, if I take A, B, C, D, E, F, this will be 41 H, this is alphabet, this is ASCII, 42 H, 43 H, 44 H, 45 H, 46 H, 'G', 'H', 'I', 'J', 'K', 'L', 'M', 'N', 'O'. So, we require only 'H', 'L' and up to 'O' only. The remaining letters I am not writing. So, this will be 47H, 48H, 49H, 50H, 51, 52, 53, 54 and 55H. Correspond to this symbol, the ASCII code is 21H. Now, I want to display hello followed by this symbol. Okay. So, what is the program for this? So, first of all you have to set the mode word register and command word register to appropriate values. The values that we have obtained are CAH and 11H. Okay. So, for that, so we have to load move AL comma CAH out FFH. So, for the interface sensitivity that we have discussed here, FFH is the address of both control word register as well as status word register. So, FFH comma AL. So, this will set mode word register as per the specifications given in the previous slide. Then you have to set command word register. The control word that we have obtained is 11H out, same FFH is the address of command word also. So, this will set command word. This is initialization. Of mode word and command words. And here we will assume that there are some locations this is the starting of data segment, say 50,000 H, and somewhere here we have 57,000 H. Here I will store hello, which is correspond to 48 H. So, I will store here 48 H, which is correspond to H. E is 45 H. I will store in the next location 45 57001 H. L is correspond to 52 H. Then again L 52 H. O is 55 H. Then this symbol is 21 H. Then I will store two more symbols here. One is called carriage return, so the corresponding symbol you have to store here, and this one is line feed. I will discuss what are these two signals. One is carriage return, second one is line feed. The code correspond to this one. You can refer in the manuals of the CRT display that we are going to use. We have the corresponding ASCII codes correspond to carriage return as well as line feed. Okay. So, these values you have to load. Totally I have load 8 different values 1, 2, 3, 4, 5, 6, 7, 8. So, the last address here will be 57007 H. So, for that the initializations are move AX comma 5000 H, because I want to store this into data segment, because the starting of data segment is this, the upper 16 bits will be stored in data segment register. So, I cannot directly take that address into data segment, I will take into AX and then I will move on to DS. Then the number of characters 8, so I will load into CX. So, the starting address of this one is 5700. So, displacement from 5000 to 5700 is 7000, that I will take into some base register, move BX comma 7000. 7000 is the offset from starting of data segment. So, after that now so we have to transmit the data LO, HELLO followed by this symbol. Then I have to transmit carriage return as well as line feed. The purpose of the carriage return is so it is used to set the screen. So, on this screen, so the starting of that particular segment. Okay. So, this carriage return is used to transfer the control to the starting of line. After hello, this again the control will comes to this point, but I have to change to the second line. So, for that we are going to use line feed. Line feed is used to return to the next line. So, with the first command carriage return, the control will comes to the starting of the line, and then with the line feed the next line. So, starting of the next line will be now pointed. So, if want to transmit any other data, so we can transmit onto the beginning of the next line. Okay. So, that is the purpose of this carriage return and lead line feed. Okay. So, I will assume that these codes are available in 57006 and 57007H. Now, I have to display the first character H, which is stored in 57000H. Okay. For that, I have to check before that whether the transmitter is ready or not, the status register. As we know that in the previous example also we have used this. So, this particular bit of status register last bit, the remaining bits we are not going to use. This is going to indicate that transmitter is ready or not. If this bit is 1, transmitter is ready, otherwise transmitter is not ready. We have to wait until the transmitter is ready before sending the first character. So, for that we have to input in, what is the address of the status register? Same, FFH, okay, in AL comma FFH. So, this will check the status of status register, to check the status register. But we are interested in only the last bit of status register. So, to get the last register, I will end this AL contents with 01H. The same logic we have used in the earlier example also. Now, in AL result can be either 00 or 01. If transmitter is ready, 01, if transmitter is not ready, 00. So, what I will do is I will check for the 0 flag, jump on 0, repeat. I have to wait until the transmitter is ready. So, where should be this repeat? This in. So, this will be repeat. Now, so as long as this is in the loop, we will wait because the transmitter is not ready. Once this come out of the loop, indicates that transmitter is ready. Now, I have to transmit the symbols, total 8 characters. So, the first character is stored in 57000H. So, I have to take move AL comma contents of BX. Now, the address will be 57000X. This is nothing but 57000H contents. So, what is there in 57000H is 48H, which is correspond to letter H. Okay. If I transmit this out onto FEH, because this is data register, I have to transmit on data register, comma AL. So, that the H will be transmitted and that will be displayed on CRT display. This is FE because I have to transmit the characters on data register. So, data register address is FEH for these interfacing connections that I have shown. Now, with this I have displayed H on the CRT display. Now, the next letter is E, which is stored in 57001. So, I have to increment this BX register and I have to decrement C, because I have already displayed one character. You decrement CX and then you increment BX. INC BX. So, decrementing the CX and checking or repeating the same operation until Cx is equal to 0 can be performed by using loop. Loop, where should be this loop? The same repeat. After each character you have to check whether the transmitter is ready or not. Okay. So, again for displaying E, I will check whether this transmitter is ready or not. If it is ready, then only I will transmit E. After that I will transmit L, again L, again O, again the character, and then carriage return, and then line feed. So, this is the program and the interfacing details of connecting a CRT display to the 8251 and then transmitting a word hello. So, these are the different examples of connecting various peripheral to the 8251 and transmitting the serial data to the serial devices. And the last peripheral device is 8279, which is programmable keyboard / display interface. This is the block diagram. 8279, which is programmable keyboard / display interface. So, in the earlier classes we have discussed about how to connect a keyboard, how to interface a keyboard to the microprocessor, how to interface a multiplexed display to the microprocessor, and we have written the programs. So, those approaches are called software approaches, whereas this 8279 is hardware approach. Then what is the need or what is the advantage of 8279 over software based keyboard interface and multiplexed display interface? Okay. So, the advantage of this hardware based is, as I have told in the earlier classes also. So, we can have the fast interfacing. So, the interfacing through 8259 or 8279 is fast. Okay. This is fast compared to software based. But the drawback is it's a costly, because you have to add a IC 8279 IC. So, this is cost. So, there will be a trade off between the cost and the speed of the operation, depends upon the applications. We have to either go for the software based approach or hardware based approach. Okay. So, now coming for the block diagram details of this 8279, which is programmable keyboard or / display interface. So, we have totally here 5 sections, because we have keyboard as well as display in the same IC. So, we have keyboard section separately, display section separately. Okay. So, these are the different signals, these are all correspond to display. These are all correspond to keyboard. This is correspond to scan, and these are all microprocessor interface signals. Which will be connected to the microprocessor. This part will be connected to keyboard, this part will be connected to display, this will be scanning, this will be useful for both keyboard as well as display. Okay. So, coming for the details. So, inside this there will be 8 by 8 first in first out RAM, and there will be a keyboard debone circuit inside the device itself, whereas in case of software approach we have to write the program for debouncing of a switch, whereas here this is there inside, and we have totally 8 RL 0 to RL 7 signals. This will be connected to eight columns of keyboard matrix. and there will be a shift signal, as the name implies. To shift the data we can use the shift signal, like in case of software also we have written the program to shift. First I will send a particular sequence and then I will shift that sequence to check all the rows and all the columns. So, like that here we have a shift signal, and this is control tab signal, which will be used for shifting and selecting the appropriate rows and columns of a key, and keyboard bounce signal is available here. So, these keys can be interfaced to 8 by 8 first in first out read only memory. So, the corresponding status can be read from here. And the scan, we have 4 lines of this scan. If I connect this 4 line to the 4 to 16 decoder, these 4 scan lines if I connect to SL3 to SL0, 4 to 16 decoder. So, these 16 outputs can be used to connect to either keyboard, these we are connected to the columns, this you can connect to the rows of keyboard. Or this can also connect to the display drivers. Of multiplexed display. Then coming for this display section, so we have display address registers, because here we have 16 by 8 display read only memory. So, 16 locations, each location is capable of storing 8 bits of the data. So, we can connect 8 different 7 segment displays. So, what is the starting address of this memory? Here we have 16 locations, this is 1, 2, 3, so on up to total 16 locations, and each location is capable of storing 8 bits of information. So, what is the starting address of this? This can be represented by using display address register. Then the contents of this display matrix will be transferred to this one, to display registers. There are 2 outlines. So, these outlines, there are 4 outlines called A, group A, and 4 outlines called group B. This is group A, group B. They can be connected together or they can be used individually also, okay, depends upon the applications. This will be given to the 7 segment displays that we are going to connect to these lines. We can control this using this display registers, and there will be some timing and control unit which controls all the operations, and there is a 8 bit data bus. So, reset signal is there, clock signal is there. Then one more signal called BD bar signal. This will be used for, if this is 0 as the name implies, this will block the display. To block the display initially we can use BD bar is equal to 0. So, whenever reset pin is there, it will reset all the internal registers, clock which is going to control the operations of this signal. Then we have read bar, write bar signal, they will be connected to the IO read and IO write of microprocessor, chip select signal. Then A0, this is similar to 8251, this can be used to select the command word or status word or data register. We can use similar type of interfacing circuitry. Then interrupt request. So, whenever this particular sensor ROM, here this can store, there is a 8 location and each location is capable of storing 8 bits of information. If any data is fed from the keyboard, if any data is filled here, so immediately this IRQ becomes 1. This is going to interrupt the microprocessor, indicates that a data is ready in the FIFO RAM. So, if this is empty, then there will be interrupt will be, this will be disabled. Whenever any data is placed into this FIFO RAM, then this interrupt will be enabled. This will be connected to one of the interrupts of the microprocessor, so that the microprocessor will complete the execution of the current instructions. It will go to the interrupt service subroutine, it will read the data corresponding to that key and it will come back. So, these are the different signals of 8279. We can interface this 8279 to 8086 in a similar manner to that of 8251. We are going to use only 8086 or the microprocessor interfacing line. Here we have some signals connected to keyboard, some signals connected to display. Keyboard signals and display signals. I am not showing here, and there are some scan signals. So, the microprocessor connected signals are, so we have chip select signal similar to this one, A0 to A0, A1, A2, so on up to A7, then read bar to IO read bar of 8086, IO read bar to write bar of 8279. Then we have clock signal, reset signal. This may not be directly connected, here we require some sort of clock division network, because the operates, you can use the clock divider to generate the clock of this one. Then coming for the addresses, similar to this previous interfacing. All these should be 1 to select the chip. The chip select will be 0 if all these bits are 1s. A0 is 0 for status and command registers, and this is 1 for data register, similar to 8251. So, this address will be FFH, this address will be FEH. So, this is how we can generate this addresses correspond to data registers and status or command registers. The formats of the command registers and data registers. So, we have similar to this 8251, here also we have different formats. I will just discuss a simple format. So, in one data registers, the format of this command word is, this is control / strobe, this is shift, and these 3 bits are for display, and these 3 bits are for keyboard. If we want to select 4x4 keyboard, we will set this as 4. If we want to use 2 displays, 0 1 0, and this should be normally 1 1. So, we can generate this is correspond to D and then 4 D 4 H. We can write D 4 H into this FEH, the status or command word register addresses. So, like that you can program, and we have different formats also, different formats of this status and control word register. We can refer to the Intel manuals of 8279. Okay. So, this is about this entire course. So, I take this opportunity to thank the NPTEL team of IIT Madras and in particular the CET of IIT Guwahati for giving this opportunity to teach this microprocessor and interfacing course. I hope you enjoyed the course. So, I wish you all the best for the final exam. Thank you.